Good afternoon or good morning, everyone. Thank you so much for joining us today for the ASTRAIOS EU-funded project. The overall goal of the project is to identify the existing space-related education and training across Europe, to project future demand for space skills across the European space industry, and also to identify actions to align and improve the career pathways into the sector. Our project started in January 2023, and we are now in the final year. Today's webinar will discuss Earth observation and geospatial data for digital twins, global perspectives for sustainable development. I would like to say thank you so much to our guest speaker, Professor Mila Koeva. Mila is our Vice Dean Research at ITC, and she's also Associate Professor in the PGM department at the faculty. So Mila, thank you for being here today. The floor is yours. Thank you.
Thank you very much, Mariana. I hope you all hear me and see the slide on the screen. It's a pleasure for me to be here and to be part of this project and to give my talk. I would like to share that in this presentation, you will see a lot of work behind, summarized in just 40 minutes. So I hope it will be interesting for you and will be open for questions later on. As Mariana nicely introduced me, I will not repeat it. I work in ITC in the University of Twente, and today I will give you a presentation on Earth observation and geospatial data for digital twins. This is a topic that I'm very passionate in the last 4 or 5 years. Let me start this talk by introducing a little bit on where we are. We are in the Netherlands, in the University of Twente. You can see on the slide a little bit about our university. And we also have 5 faculties. We are located and we are working in the Faculty of Geoinformation Science and Earth Observation. Why I am introducing this is because I want to give you an overview. What do we teach and what our research includes? When you look at the screen, you can see that we work a lot with variety of geospatial data, starting from satellite, aerial images, fieldwork data, citizen data. And when gathering all this data, we think how to visualize it, how to make it usable for users in an online or dashboard environment. And if you look at the right side of the screen, then we go through the time of data analysis, data simulation, and then the topic of digital twins comes. So why I was saying this is that digital twin is some kind of an umbrella topic for which you need knowledge or pre-knowledge on all these mentioned on these slides, approaches and data collections and methods. So why do we need all this? You will see in my next slides, because we need to combine a lot of methods and data to reach to a digital twin. On this slide, you can see that in the University of Twente, we have this digital twin GeoHub, which is a voluntary group of people in the university from different faculties that work together on the topic. I have the privilege to lead this group, and I am happy to receive more members of it. So if you're interested, please don't hesitate to contact me and join our research on the topic. So let me give you a very short history how all this digital twin topic came so popular and where did it started. It started from the very beginning from NASA when they were producing different models or replica of airplanes or rockets before launching them. So basically the main idea was a real-time simulation and what will happen if we launch this airplane or rocket. So it is all about digital representation of something physical and the connection between the physical and this digital representation. Later, this was very long ago, basically in the 1950s, but the domain of digital twins became later on popular in the field of city planning, urban planning, and you can see on the slides that we can have it applied in different scales, on a building level, on a city level, or even on the earth level. I want to start with a small definition of what are digital twins, or what do we understand by digital twins. So it's a digital replica of our physical environment, as I already mentioned, mainly to support decision making. And how do we make that? We do it via replicating our cities or buildings or our environment and establishing a continuous link between the physical and digital world. This link can be based on historical data, near real-time data, or real-time data. This would be the best approach if possible. But as you can see, to create such type of digital replica, we need to come or to pass through all the phases that are on this circle on the screen, from data collection, data integration, where we integrate all possible geospatial, remote sensing data, or citizen science data. Then we go through the processing, and only after that we can reach to analytical and simulation capabilities of the digital twin, where we can give some insights to the decision makers. So this is a nice schematical overview on what are digital twins. I want to start this video, which is a YouTube video where you can see a little bit on the idea behind the digital twins. So it can also be applied, as I mentioned, on an earth level, not necessarily only on a city level. So we can understand some problems that are world related. We can do predictions, we can do simulations with the highly detailed interactive data. And all this is to support fair decision making. It can be very much related to climate adaptation, simulating weather events or some extreme event. We have been working on disaster management, disaster response, for example, or climate mitigation. You can see that with the power of digital twins, we can simulate different scenarios so that we are a bit more prepared. What if this happened? How should people react? What would be the first measures? And so on. Feel free to look at the video offline and to, let's say, learn how to do all this, what are the available resources. But as you can see, it's a complicated software infrastructure. There is no one approach to solve the problem. It's really an integration of multiple approaches, nowadays very much empowered by AI and automation, since a lot of data is involved in these processes. I want to just share with you some kind of maturity levels of the digital twins, because as mentioned, it's a complicated system, so we cannot for every case reach the best or the highest maturity level. Sometimes we only reach a visualization, which is very coming into the category of awareness. Or we can have visualization and simulation capabilities, which we can make several experiments. The best is if we reach to analytical capabilities with the digital twin, where we can do predictions and simulate our future interventions. And to be very honest, I have not seen the last one, the fully autonomous digital twins, which we call intelligent ones, where basically they will suggest users already autonomously the decisions. Maybe they exist, but according to my knowledge, we have mostly reached to the predictive ones, analytical ones, which is already quite a big achievement. Let me share with you how do we approach the topic of digital twins here in the University of Twente and ITC. Since our main core expertise is working with Earth observation data and geospatial information, as you can imagine, we always start with what sensors are there available, what platforms are there that can support us with Earth observation data. Do we have image data sources or point cloud data sources or maps that we can use and integrate in our digital twins? And then we also think about how can we use these automatic processes like AI to extract only the meaningful information that we need from these sources. And then we can use, of course, cloud computing, 3D databases, so that we can store, visualize, and efficiently share our outputs. So more or less, this is the circle that we follow in the topic of digital twins. We think how to collect, how to visualize, analyze, share data, and also how to manage data. Since in every project, we collect tremendous amount of data, and that is one of the biggest problems, how to integrate or how to share. On this screen, you have some of the bullet points that are giving you an answer why do we need digital twins. It's always related to tackling different sustainable development goals. Of course, we are not able to do all of them, but there are many that we can, let's see, help to tackle with simulation approaches and predictive approaches, which are driven by digital twins. And I'm very passionate to share with you some of our examples, because up to now we were kind of focusing on what are these digital twins, what are the observation data we can use, how we do it, and why do we do it. But it's always interesting to show you some practical examples. On this screen, you can see more or less the areas that we have been explored. So digital twins for mitigating urban heat island, waste management, water management, disaster response, urban planning and land management, and traffic management. I will show you some of those examples. We have many here in research basically focusing on developing machine learning algorithm that can make faster predictions in relation to weather research and forecasting. There are a lot of physical models related to that, but physical modeling, as you can see, due to scarcity and empirical data, are very heavy and very complex. So with machine learning, we were trying to kind of make this process of initial data on urban heat more accessible and fastly computed. You can see that we used in this research random forest, which is a very simple machine learning model, and we kind of managed to reach quite a high accuracy. So using this approach, we can gather preliminary data for digital twins. To simulate urban heat island, we'd also need, apart from temperature predictions and temperature values for verification and validation, we need also to take into account solar elevation, solar radiation, wind direction, wind speed, and so on. So most of our research on urban heat was based on this formula for calculating this physical equivalent temperature, so how the physical body of a human will respond to changes in temperature. I will show you the very beginning of this research, which was, of course, focused in the city where we are located here in the university. It's the city of Enschede. We collected in a GIS database, initially all Earth observation data and geospatial data existing in Enschede. We visualized it and we tried to think of prediction of the urban heat. The raster vector, the raster layer that you see here with dark red is the prediction. And then our students were playing with some game engines to kind of simulate with the top view and first navigation person view, how would the human body feel walking on the streets of the city based on these predictions. But this was a very, very first initial research where we were just looking with raster data and working with raster outputs. Then we slowly started developing GIS tools that are currently embedded in the municipality of Enschede, and they're working with them, where people can just put water bodies or vegetation or new buildings. You can see here in pink are the new added trees. And the municipality workers can just press a button, which can give them a predicted values of the urban heat based on their interventions. So you can see the output of this research on the QR links on the slides. But this was not the end of this research. We continued with urban heat in the city of Padua in Italy, where the temperatures are rising really high, like 40, 45 degrees is a standard temperature in the summer, and it really affects many people there. So this was an ESA-funded project where we developed an application that can simulate and predict urban heat in Padua. Again, the principle is similar. We collected data. There were, I will directly show you the application here. So this is a very simplified visualization because the workers in the municipality have to be able in their daily life to use it. So basically you have integration of a weather forecast in the upper corner. You have integration of remote sensing data, GIS data, and the more important is 109 physical weather sensor data located in this area, which are continuously giving real-time temperature data. So what you can also see in this video is that, again, people with simple tools in the municipality can just make some interventions like putting buildings, trees, and water bodies, and they can have a simulation of their impact, similar to the previous one, but with a little bit more deep analysis. There is also in the blue part of the screen, you can see there is an economical analysis. So what would that cost? How much would we gain based on our interventions? And also there is a red button, if you can see on the left side on the screen, which is giving automatically a notification to the citizens if the predicting temperature, let's say tomorrow, will be very high. Don't go to this or that street on the city. So there is a full cycle support. With this digital twin, we support decision makers in the municipalities, but also citizens. So that was the research in Italy. We have again continued it in relation to shadow analysis, how many solar panels we could put on, let's say, roofs of the buildings, what would be the exposure, what would be the minimum number. And this research has given us what-if scenarios. So, for example, if you see on the right side on the screen, if we put one tall building in this orientation, what would be the impact on the heat? If we put 3 tall buildings with this kind of orientation, like on the third picture, what would be the impact? So you can see that having these simulation tools, you can really predict and have some assessment. I have here again a video with this scenario of 1 building, 2 buildings, 3 buildings, and so on. If you're interested, again, there's links, there are QR codes that you can visit later. Urban heat was also a popular topic in Germany. where we have developed also this visualization here, which is based on the same theoretical principles, but a little bit different functionalities. That's why I'm not going to go deeper into the topic. It's a little bit more real-time and realistic kind of visualization, but again, based on real-time data with predictive capabilities. There was a small research related on green roofs. What if we put green roofs and we compare them with the white roofs, and we put sensors on many roofs in the Netherlands and we put sensors on the ground? Then we did quite some comparison and analysis on the impact on the green roofs. All this was related with urban heat. I want to show you some related topics to digital twins, but with water and flooding. This was again an ESA is Earth Science as a project, which related to flooding and water. And here it's related to Caribbean island with Dominica. And what we have done is using Earth observation data, terrain modeling, and 3D modeling of buildings, assessing what if there will be flood. And this is something that has been happening pretty often and can impact many citizens. So there was quite a deep analysis on that. I can show you on this small video also a bit of a simulation. It's really very kind of small simulation of how this flood can look like and which houses would be impacted. And also, this was the latest, again, developed application, again, for the Dominica, called GeoTwin. It is a fully open application. You can see on the QR code and also on the link below for flood simulation. Basically, the platform downloads a water height data and turns it into flood polygons for real-time 3D visualization. It is using terrain rendering, water shading, and there is quite some semi-transparent surfaces. You can see here how we model the 3D houses, and from the left side on the screen, you can see the slide bars where the users can play. What if the water level rises to this level? What will happen? Then you can see later in this video, there is assessment, impact assessment, where it is showing how many houses will be affected, how many people will be affected, what could be the mitigation, let's say, measures, and so on. Yeah. Let me speed a little bit this video because I have quite a lot more to show you. But you can see here on a residence level, we can have an information of who, where, how will be affected. And a lot of other things you can see with this GeoTwin application. So you can play with it and yeah, make your own scenarios. Again, on the water management topic, we have a lot related to impact on the physical world. These are some of the examples that I really like because we have integrated many sensors and made a 3D overground and underground city model. And based on the sensor data, we can predict where the pumps in reality have to start pumping the water out. So currently in the Netherlands, when there is a flood, manually there are workers that are going and switching on the pumps or opening the manholes on the street so that the water goes out. So with our machine learning algorithm embedded in the digital twin, this can happen automatically. So when we predict that the water will rise, those pumps will automatically be started. Similar approach is used to this application. 10 meters. They are subdivided into 10 meters, and we have positioned possible barriers that will be physically installed in reality. So every point represents a graph on the right. It can be visualizing if the water goes up, how these barriers, when these barriers should be opened and closed, to what level these barriers should be opened and closed. So the red line represents the level of the groundwater, and the yellow line represents, let's say, the predicted water level, and when they touch, the barrier should be lowered. So this big number that you see on the screen is proposed location or position of the barrier. So this is a really very good example because it's also currently being used and implemented in the municipality of Enschede. I will also speed a little bit the video, but you can see how do we work. So it's a real-time manipulation in the map. So you can make your own pipes, you can make your own let's say barriers, and you can see when they are going to be open, closed, and to what level they should be open and closed when the water will rise. I'm just showing you a little bit how in 3D those barriers look like and how do they block the pipes. So all these are projects that are being installed in the municipality and really being implemented. I want to show you some other examples related to transport modeling. How can we use digital twins? So in this case, we have a very busy traffic road on one crossroad, and we have 6 LiDAR scanners, which are continuously giving us LiDAR data. The first task with it, and I would say even the hardest one, was to do the automatic classification of the moving vehicles. This is the second video in the middle of this screen with the dots that are continuously being changed. So this video is showing in real time, because this laser data is continuously being broadcasted. In real time, you basically see the flow of the vehicles on this road. Then, if you go on the first video on the bottom, I will now switch it on. This is the real-time situation on this crossroad now, with the traffic lights and with the cars passing through this crossroad. Having all this data in real time, what we did is to make scenarios. What if we build a roundabout in this crossroad? How would be how would the cars or vehicles behave if there is a roundabout? You can see the middle bottom example on that. Then I will switch now this video. Again, what would happen if we make 8-shape road? How would the cars behave with this type of road construction? And now I will switch the upper right video just to show you that we can also make simulation of what if we make 2 roads, one on top of each other, and we simulate the behavior of the cars with this in this 3D, let's say, environment. So all this is to show you, again, an example of a digital data integrated in a platform, simulating many, many scenarios, fulfilling the task of a digital twin. We had another example for waste management that actually was a research that got the best second award in the Netherlands 2 years ago. It was related to a platform from South Africa related to waste management. We have integrated multiple sensors put in the waste containers in the city, and also we have integrated application data coming from an application from the phone of the citizens who were giving us real-time data where there are illegal dumpings of waste. So having all this input information, we have built an algorithm that is automatically navigating the trucks and that are responsible for collecting the waste in the city. So with this work, we have also have quite some predictive analysis, scenario simulation, but also route optimization. If you want to learn more, there is a QR code and links on the slides. I'm speeding up because I have some more examples. For example, this is related to air pollution. This is one of the, I would say, hardest research up to now that we have done on digital twins, because air quality is something that is very, very hard to model. You can see that we have developed an open source, completely open source tool that can simulate urban digital twin for air pollution analysis. It integrates again geospatial, earth observation, real-time sensor data, and also gives predictions. So these are the locations on the screen of the stations where we have measurements of the air quality. So we have 20 of those around the city of Sofia, in this case, in Bulgaria. And we have also traffic data, building data, meteorological data integrated so that we can predict the concentration of pollution of nitrogen dioxide and PM2. And basically, with this approach, we can simulate what will happen if the pollution in certain areas is increasing. Also, we can simulate what is affecting this air pollution increase. And also we can, urban planners can test different interventions from that. Let me see, how far is this video? Yes. Okay. Final, let's say, examples related to asset management. We have been working here. The photogrammetry is based approach for this research. We have put cameras on service trucks that are continuously circulating in the road network of the city of Johannesburg. And we have some automatic recognition algorithm that is recognizing where are damages on the roads, on the road network. So the damages are classified in yellow, green, and red. You can imagine that this corresponds to the urgency, where there are urgent intervention needed. And this is a continuously dynamic approach because the data is continuously being collected. Information is given to the respective authority so that they go and, let's say, do their interventions on the road. I would like to finish this presentation with saying that we don't do this research in isolation. We always do this, or we try to do it in collaboration with stakeholders from municipalities, so that we can have really impact, so that our solutions are not ending up only theoretically, but they are implemented and they are useful for planners or even citizens where applicable. And on the last slide, I want to tell you also what are our challenges and where the opportunities stand. You can see that the main challenges are related with variety of data integrations, data interoperability, collaboration between governmental sector, private sector, and research authorities like research organizations like us. So where data is allowed to be used, where it's not. There is still very much a challenge to get real-time data so that we establish this continuous link between the physical and digital environment. And we are currently very much focused in developing AI algorithms or predictive models so that we can make our simulations accurate and include AI on that. There are multiple researches going on, also related to developing LLMs and chat boxes to make the users, let's say, interact easily with the model. So ask questions so that the model can directly show them the answers on the geospatial environment. That was my presentation. Thank you for your attention. I'm happy to answer your questions if there is time. And if you have other questions outside of this webinar, I'm also happy to answer them offline. Thank you very much.
Thank you so much, Mila. Thank you so much for this very interesting presentation. You provide us a very good overview of what digital twins are, why we are building them, and of course, what are the challenges and the constraints that we need to face. And it was also interesting to see that you apply this technology across so many different application domains. Thank you so much for sharing this interesting information. I see a hand raised, so I kindly ask you to put your question on the chat. Now I will start. There are actually a lot of questions, and I will try to pick up a few of them and try to answer them in the remaining time. So I think the first question is related to the general introduction of the digital twin. When you mentioned that so you have different levels, and now it's very difficult to go from the analytical to the, I think you call it intelligent one, the next level.
Yeah.
So what are the constraints? What do we need to do in order to enable this transition?
So from one side, there is a big opposition of giving all power to a computer to take the decisions completely autonomous and to take the power of the, let's say, humans, like, or working in the municipalities to take their decisions. So we don't want to take this power completely. So from one side, this is the challenge. It's more of a human, let's say, challenge, because we would like still the decisions to be taken by us, by humans, rather than completely autonomous, predicted and supplied by the digital twin based on automatic algorithms. So that's one story. The other story is that we still don't have such predictive models or autonomous models that we can say, okay, we trust them fully and we can rely on them. So as I mentioned, we reach to analytical level predictive models that can supply our decision making, but we've never reached to such an autonomous models. So there is a lot of validations to be done, a lot of verifications until we also kind of try trusting them completely.
Great. So I will continue the discussion on more challenges. And the question is related to the challenges you are facing for building the digital twins. Are they structural, governance related, technological, or more related to data availability, quality, organizational and stakeholder alignment issues, or maybe all of them? I think the connection is not.
Yeah. So starting from the technical part, do you hear me?
Yes.
Do you hear me? Yeah. Okay. Yes. So from a technical perspective, there are challenges related to data availability, data interoperability. There is no one approach that fits all purposes. So for every single case related, for example, to a certain domain, air, transport, water, heat, energy, you have to have an individual approach. So there is no one method that can serve them all. So you have to always find the best, let's say, method combination so that you tackle the right problem. And of course, there are some commercial, let's say, approaches, but we as university, we try everything to develop in open source. So we are having this time constraints of developing our own methodological workflows so that we have ready solutions to be used. So that's also a constraint. One other thing is that there is, in many countries, I don't talk only about Netherlands, but in many countries, data sharing and data exchange is still an issue. So open data doesn't exist everywhere. And until we get to the needed data, the project may be halfway through. And that is still a problem. And of course, there is readiness level. Depending on the organizations, depending on the stakeholders, in some places we are facing challenges related to the knowledge that they have in using our approaches. So are they ready to use such type of approaches in reality? So we need to take this as a complex system every time that is, let's say, tackled to the exact needs of the concrete users and concrete domain.
Thank you. It seems that the citizen science or the involvement of the citizens is an important component of your work. Can you share a bit with us what are the challenges, or how do you engage with the citizens and also with the local stakeholders, and what is your strategy?
So we try to develop outputs that are pretty easy, let's say, to use. If you look at the APIs that I have shown on the screen, they don't look so complicated. Even behind the scene, believe me, it's something pretty complex. So first of all, we try to develop different levels. One are to be used by the municipality workers, let's say, or employees. And there they can do a little bit more complicated analysis and do their simulations. But we have also those developments that are really for the applications for the phones where we collect citizen data. So there they can simply make small geospatial operations, locate themselves somewhere in the environment, put a point or share a picture or give a feedback. So trying to collect their input in the most simple way possible, but still taking their input into account.
Great, thank you. Now there is a technical question. How do you see machine learning and deep learning advancing the automation of digital twin updates, especially in complex environments prone to multi-hazard risks, such as landslides, flood, coastal hazards?
I see the machine learning or AI in general embedded in every stage of building digital twins. So we are using it from the data interpretation. When we have data, we have to extract meaningful data out of what we have there. So machine learning can be in this stage, but also in the processing part, also in the analysis part. In every stage of building a digital twin system, you can use machine learning. And also in the chat box that I said, and the LLMs that now we are focused to interact with this digital twin system. So in every stage, we can use machine learning. For the disaster management or for the concrete question, again, you can use it from the side of manipulations related to Earth observation data, terrain modeling, and so on, but also with the predictions, how many people will be affected, which houses will be affected. These are all algorithms that can be used in the predictive part of the simulations or whatever, related to disaster.
Yeah.
In our case, I was working more on the flooding, as you can see, that type of disasters. I have not experienced any example related to landslides.
So then it's a very good bridge to the next question. One of the participants wanted to know whether you use fast flood for the flood analysis that you present. So the quick answer is yeah.
Yes. Great. So I can share where were the slides, but these are two different research lines. based are both on the fast flood application. So the first one, just a second, let me reach this slide. Yeah, this one was the first one. Yeah, this one, where the basis is the fast flood application. And what we have done is be more focused on the 3D embedded in the fast flood application and simulations in the 3D. This was one. Then this was based on UAV data, drone data, and simulations again related to the terrain, but is again the data is coming from the fast flood. And this one is also completely using fast flood.
Yeah? Okay, that's good to know. Thank you for that. Once the digital twin is built, how do you update it? So
that's a good one. So the idea is that the sensor data doesn't need updating because it should be continuously there, the real-time or near real-time link. This doesn't need updating, but for example, the geospatial data, the remote sensing data, this should be updated because our real environment is always changing. So I agree that this is kind of a challenging question, but we need to take into account this. So the thing is that when you produce such an open source application and you give it to the stakeholders, they should have to be able to update the input information by themselves. So the GIS, they can simply update it because they are the owners, usually in the municipalities. So it's in their hand, the updating, because they need reliable predictive models afterwards.
Great. So we also have participants from South Africa and Saudi Arabia who would like to connect with you. We'll share with you the contact details. They are working on disaster management and also on decreasing the temperature in urban areas, and they found your presentation very interesting and they would like to connect.
Welcome.
There is also a question on the type of applications of the digital twin. One of the participants would like to know whether you have such an application for land valuation.
Land valuation is a very tricky question. I am in the Department of Land Management, and I can say that I know quite a lot of this on this topic. We have a lot of work related. I can share papers with 3D land valuation. So we are building 3D models, and we analyze the different prices on the, let's say, properties in terms of
the connection is
third dimension.
I think now you are back. Can you please repeat? Sorry. Yeah.
Sorry. So there is a lot on 3D valuation. You can see in our research under my name, there is a lot on 3D valuation, but we don't relate it so much into the digital twin topic because it's not something that you can have in real time. So we have not really, it can be done, for example, with near real-time data, but to be very honest with you, prices of properties are not easy to be obtained. We have been working on this topic with many countries, and you either have average prices per land or per property, or average price per building. For example, we had to work a lot in China, 3D land evaluation, and there the buildings are 20, 30, 40 stores, and the prices are different per level. And it's very hard to get such detailed and almost impossible near real-time price information so that you can build a dynamic digital twin. You can have what we have managed to reach, 3D or 4D land valuation.
Great. We will take two more questions. One of them is also technical, and the second one is a bit more generic. So how can you use digital twin models and predictive analytics or how to integrate them with space weather anomaly detection to improve human and societal services?
You can look at, I had a small video in the very beginning, if you had seen, what is being provided from the Destination Earth here, this one. Destination Earth and digital twins. So if you look at this link, and if you look at also the what has been shared, so these are global big projects that are related on sharing Earth observation data and climate data worldwide, and there we can really do some predictions on this scale in relating to weather forecasts and big events. So you can really go to the available repositories, and even there is a lot, everything is open source, so you can really look at what is being developed there.
Great, thank you. And the last questions is related to the capacity building activities. The digital twin, as you said, seems to be a very complex systems. So in order to learn how to build digital systems, how to manage them, and how to apply them with the right governance, you need specific tools. So what would be, not tools, but skills and competencies? So what would be, let's say, top 5 skills or competencies that are needed in order to make sure that we have sustainable, fair, operational digital twins across different domains?
Okay, so I will start with programming skills, because nowadays I think this is impossible without some programming skills. Recently, most of our researchers and students, they are using Python, but depending on the output necessary, sometimes they can use C# or JavaScript just for the final visualization. But Python is essential. For all this data integration that we have been discussing, of course, knowledge on GIS and Earth observation data is needed, but also how to integrate in a 3D databases, and how to manipulate or organize, store, share, and do some interventions with this data. So Python, GIS, Earth observation data, data storing and sharing in databases, I'm up to 4. Let me come up with 5. The 5th one is domain-specific data, let's put it that way, because we have different skills needed to work with the concrete domain.
So besides these, let's say, domain-specific skills, I assume that we also need what we call soft skills, or transferable skills, I think, teamwork, capacity to work in interdisciplinary and multidisciplinary teams, because the systems are complex. I assume this is a key. Is there anything else in terms of these transversal or soft skills?
Yeah, I agree with you. That's why usually the digital twin in our education comes towards the end. So our students are learning the basis of different, let's say, with different courses, like from GIS, Earth observation, machine learning, Python coding, data storage, and only after that they come to implement all this combination of knowledge into the digital twin domain. But that's true. It's a multidisciplinary approach needed, multidisciplinary knowledge, and a little bit of open-mindedness. I would make it a bit more generic, but you should really be creative and open-minded if you want to create something that is useful at the end.
Thank you so much, Mila. It was such a great overview of what digital twins represent and the latest trends, and also the application of these digital twins across different domains. That was very interesting to see. Our participants are asking whether they will have access to the recording. The recording of this webinar, but also the other webinars that have been hosted by ASTRAIOS, are hosted on the ASTRAIOS project website. So please check our website and you'll see this recording and the other webinars. Mila, thank you so much again, and thank you to all the participants for attending our webinar. I wish you all a great day. Bye-bye.
Thank you, everybody. Goodbye.